We are using a Cisco switch and an Engenius wireless access point, and we're going to set up a configuration where the guest wireless traffic is separated from the wireless traffic used for internal communications to your servers. So that way you can separate when visitors come over so they can't get access to any of your internal equipment. All right, so let's start out with our switch. Now, this particular switch is a Cisco 3650. It is a switch that is capable of what's called inter-VLAN routing. Now, not all switches are capable of that, so if you don't have a switch that can do this, then you either need to get one or you need to get a Cisco router that will do the routing between the VLANs for you. But that'll be for a different video. So let's just assume that you have a Cisco switch that's capable of inter-VLAN routing, and you can check with Cisco's website if you are not sure. And let's talk about how we're going to set that up. Now, for our first line, for our default gateway, of course, all switches need a default gateway so they know how to get their attached devices out to the network or the internet. And after you type the default gateway, then you need to go on to IP routing. Now, the IP routing piece is only if your switch supports the inter-VLAN routing. Otherwise, it's pointless to type that in because it doesn't do it. So you would have to do that through your router itself. So if your switch does support that, then the next thing you want to do is type IP route, and then what you see here, all zeros, and then the gateway of 10101, if that is truly your gateway. Of course, you have to use whatever your firewall is or core switch gateway. Now, the reason you have to do both of them is the default gateway only works before you turn routing on. After you turn routing on, you have to do the IP route command. Otherwise, the default gateway command becomes useless. So again, if your switch does routing, put in IP routing, put in the route. All right, let's move on to the next piece. We have to add in a dhcp pool. Now, this is just for the wireless itself. You can still use your dhcp pool on your Windows Server or other device if you want to, or you can put it on the switch itself. But the wireless for guest needs to be on the switch where we're setting this all up. So let's take a look here. We have an IP dhcp pool command under the global configuration, so config space terminal. Will get you to this particular command where you can type it in. Now, I put in guest Wi-Fi, but you can type in any type of name that you want. This is up to you. After this part, you can put in the name of your choice. I just chose guest Wi-Fi because it was easy to figure out what that's for. Now, I put in my network as going to be 10.40.0.0 and with a /16-bit subnet mask. You can, of course, put anything you like, any subnet you like. The most common, of course, is the 255.3x.0, which is known as a /24 mask. So let's go ahead and put that back in the way it was. Now we have a default router IP address of 10.40.1.1. Now, you're probably wondering where we got that. Well, that comes later on down in the configuration. And then we want to put in our DNS servers. Now, I just went ahead and put in Google's IP addresses, but you can put in whatever DNS servers you want. You don't want to put in the internal DNS servers of the network because we're going to be blocking access to that. So you just want to make sure you have public DNS servers. All right, let's move on to our interface. Now, I'm choosing to use the port 5 interface on our switch. So Gigabit Ethernet 1 stands for switch number 1, port number 5. So that's the one I choose. You might have multiple ports. You might have a different port number. It doesn't matter. You're going to set them all up exactly the same way. So you're going to be, again, in configuration terminal mode, type in interface Gigabit Ethernet 1/0/5. Again, if your port is port 5. Otherwise, if it's 10, put in 10. Then you want to type in switch port mode trunk. Now, the reason for that is because we're going to be communicating with more than one VLAN on the same port. So you need to trunk that port in order to make that happen. If you are connecting to a single device and a single VLAN, then you would want to do a switch port mode access. But we're connecting to a single device with multiple VLANs. So you have to trunk it. Next thing is you want to do spanning tree port fast disable. Now, the reason for that is because whenever you trunk a port, spanning tree port fast can cause problems. So if you are in switch mode, port fast is fine. It helps you to reconnect and keeps the switch port from going into a sleep mode with your network card. But when you're in trunking, you want to definitely turn that off. All right, so now we've assigned our interface to number 5. We want to create a couple of VLANs. Now, every other port except for port 5 is going to be VLAN 1. You don't have to tell all the other switch ports that they're going to be VLAN 1. They're just VLAN 1 by default. However, you do have to create an IP address for the VLAN 1 to work properly. So you type in interface VLAN 1. Now I put in a description, which doesn't actually change anything. It's just for your own internal information. So I said my description for VLAN 1 is going to be internal LAN. I put in my IP address of 10.102. Since my firewall is 10.101, I don't want to cause any conflict, so I chose the next IP address up on the list that I know is not in my DHCP scope. I used the same subnet mask as I did before, so that way it matches. And I put in a no IP route cache, and you don't have to put that in, that's up to you. All right, so the next thing I did is I created a VLAN 40, and you simply type in interface VLAN 40 at the command prompt. That's all you do in your configuration terminal. Then again, I put a description and made it the wireless guest network. And I made the IP address of 10.40.1.1. And again, with the same subnet mask. You don't want to be mixing subnet masks up, or you could cause some routing problems unless you really know what you're doing. All right, and then I also put in an IP access group list, which I'll explain a little later. So hold on to that thought. So now we have our interface VLAN 1 or interface VLAN 40. All right, the next thing we've got is IP access list extended block guest. So we don't want to allow the traffic from the guest network into the internal network, so we have to create an access list, similar to creating an access list on a firewall. So go ahead and create this access list by typing in IP access list and then extended, so you have extended commands capable. And I called it block guest, but you can call it anything you want. That was my own personal preference on that. Now, the next thing you want to do is deny, let's get rid of the spaces there, deny IP any and 10.0.0.0 and then 0.255.255.255. Okay, and the reason for that is because I needed the wireless to access 10.1.0.1, but after you get to .254, I didn't want it to access anything above that. And that's where all my servers and workstations live, is above that particular subnet. So you can go ahead and put in, again, anything you want at this point. That's just the one that I chose. And actually, there's a little mistake on that one, so I want to put in 10.1.0. There we go. So now from 10.1.0.1 through 10.1.0.254, the guest wireless cannot access anything above that amount, but they can go 10.1.0.1 through 254, which is simply where my firewall is. There's nothing else that lives there. And then I did a permit IP any, so you have to follow up a deny command, all your deny commands, with a permit command. Otherwise, all your traffic is denied. And it has to be at the very last thing. So if I added another line later on to block, say, a 172 address, then I have to delete my permit IP any and then re-add it again, and it automatically puts it at the bottom of the list. You can also specify the line number if you want, but this is just a much simpler way of doing it. All right, and then we've got our interface VLAN 40 IP access root group define guest in. Actually, let's change that one to let's go ahead and change that to block guest. So that matches that same access list. All right, so when I type this in, it'll actually show up in this list right here. So you just have to type interface VLAN 40 and then type this command, and then when you do a show run command, then this is how VLAN 40 is going to look. So you've got these two lines here are the important ones after the VLAN 40. So the first one gives it the IP address. The second one binds the access list to the VLAN itself. All right, so now our configuration is all done. And now we can go into our access point. So we're in our Engenius access point, and you can see here that we've got a couple of SSIDs already created. So if you want to, you can add additional ones here just by checking the box enable and clicking edit. And if you click edit, you can go in and you can type in an SSID you want, or just choose the default that it comes with, of course, which is not very descriptive. You give it a VLAN ID number of your choice, and you can also suppress the SSID so it's not broadcasted, and you can also do a station separation, enable or disable. Now don't change these boxes right here, because this has been superseded in the latest version. Security mode, of course, it's up to you if you want to do disabled for your guest access or your internal access, but of course I don't recommend it. You probably should do the WPA2 pre-shared key is the most common one, and that's pretty secure. All right, so I've already created my two SSIDs, and I've enabled both of them. And when I clicked the edit button, I chose VLAN 1 for the first one, or that's what it is by default, and VLAN 40 for the second one. Because if you remember from our configuration, the wireless SSID is tied to interface VLAN 40. And then the last thing you want to do is go to the isolation button. Now, in some of the directions on Engenius, they say to check isolation on both of the SSIDs. And what I found is that's not the case. You only want to check the isolation on the guest one. So if you create additional guest SSIDs, check the isolation for those. Additional LAN ones, don't check the isolation. Otherwise, the internal one won't work right. All right, once you make those changes, you click Accept here. And then up here, you're going to see a save reload. So you're going to click on save reload, and then it restarts the server, or restarts the wireless access point. So you have to do both of these, because accept only doesn't save the command. It only saves it just for this one page, but it doesn't save it to the device itself. You got to go into the save reload and then click that button after you make a change. All right, and that's pretty much it. So now when you connect your devices, you'll see two different SSIDs, a guest and a wireless. And for the internal, they'll get the IP from your DHCP on your server, assuming that you have one. And for your guest wireless, they'll get the DHCP IP address from the switch that we just set up.